Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to be unboxing a Fnirsi SG003A. Now, back on the 1st of April in 2022, I actually unboxed this one. This is basically what I'm planning on unboxing today, but this is an older model, and when I tried to do a firmware update, I managed to brick it. So this one at the time, you can see the terminals at the top and the wires or cable test plugs that came with it. And it had a little manual and a USB cable for charging it. So after bricking it, I put an order in and got another one coming. And now that it's arrived, this one cost me just under $80 Australian delivered. And it looks a little bit different. So let's open it up and see what it looks like. Okay, so in the box we've got our QC card. I noticed Fnirsi likes to put these in everything they make. We get an operating manual. Now this is not as thick as the original operating manual. So you can see the old one had a lot more in it. And it does pretty much everything the other one did. But I did find there's a couple of interesting extras in this one. It has conversion of engineering quantity display. So if you're connecting this up to, say, a pressure sensor, 4 to 20 milliamp, you can actually add the engineering units so you can see what it's actually showing. You can also program the output, provide a real-time curve, and there's also a Modbus slave here. It can communicate with configuration software or PLC via RS485. Set the instrument. And then of course you can do firmware updates. Interface terminals are on the top, same as the other one. Type-C port for charging, which is what the other one had, and a single power button. Now, the other one had an on-off switch here, a charge light, and the USB. It looks like it's got the same number of buttons. We'll open it up in a sec and we'll have a look and see everything else that it's got. It looks like it's got more features in it though, and it's got a frequency output as well. So just 24-volt loop detection. It's got extensions for the engineering, program output, signal conversion. This is an interesting one. Preset value, real-time curve, output time, and communications. And how to connect up for a number of different tests. Fault resolution, equipment maintenance, firmware upgrade, and product information. And then it's got a heap of Modbus register addresses. So this is interesting. If I can figure out how to get the Modbus side to work, that would be a very handy feature. Okay, so let's open it up. We've got a bag in here with the new instrument. And this is our new unit. Now it's physically bigger than the old one. The terminals on the top are also bigger. On the bottom, you've just got the single button and the USB-C. and that button lights up when you plug it into charge. On the back, there's not much difference. It's a bit better on the grip. Alright, so in the box we have a USB type A to USB-C for charging, a USB-A power charging block for European countries. When selecting this, there was a choice of two. You could go for Europe or you could go for US. In this case, I went with the Europe one. Alright, so these cables are actually quite good, or at least they feel quite good. So I'd say about 1 meter long. When you compare that to what the original one came with, very different. So they're at least twice as long. More than twice as long. That's a proper banana plug size. And the alligator clip is a far better alligator clipper as well. So they've improved on what's come with the meter as well. So each of the cables is color coded to match the colors on the top of the meter. And that's all there is in the box. Alright, let's power it up and see what we get. So this looks pretty good. So we have voltage input and loop for the 20 milliamp. Now I haven't got anything here to test the current capability of it, but I do have in my collection a calibrated voltage source. So if I grab it, and we'll give it a try, see what it looks like. Okay, so there's my output. So input, current and voltage frequency. That works. So I think this has given me a bit of an error on how to connect it. Let's try here. And it is showing me 10 volts, which is what's programmed at the moment. So let's set 5 volts, 4.98, and this is 4.9901. So it's pretty close. I'm quite happy with that. I don't know that I can get that to get any clearer on my camera. There we go. 4.98, and according to my calibration for this, the 5 volt output is 4.9901. So it does work. It seems to be pretty close to right. I'll try one of the other voltages. So at 2.5 volts, my test source is 2.4968, and I've got 2.49. It's flicking between 2.48 and 2.49, so I'm going to call that pretty close. So I don't have anything else that I can really test it with here, but I will give this a try in a factory environment and see how it works there. So that will do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account and YouTube membership, and you can join my VIP patrons Go Lucky, Copernicus and Jeff Jerd, or my Builder patrons Al Morales45, Andrew Cardone, Airgar69 and James Kelly in helping to support the channel. All my patrons get these videos a week early compared to the normal release on YouTube. If you've got any questions, either leave a comment below or drop into the Discord and ask your question there, and I'll do my best to answer the question there. And we'll see you in the next video.